Now we'll see the next type of flip-flop, that is D type flip-flop. So D flip-flop is nothing but data flip-flop or delay flip-flop. It is the modified form of the SR flip-flop, and it has single input and two outputs. So that has the single input we can consider as the D, and the two outputs we can consider as the normal output, and another one is inverted output. So this inverted output sometimes we can call it as also complement. Okay, so that means exactly normal output is opposite of the complement output. Okay, so this is the D type flip-flop. Now we'll see the block diagram of D type flip-flop. So this is the block diagram we are having. So it consists of the one input and two outputs, and also we are having one clock pulse. So that is also considered as like a CP. Okay, so with the help of clock signal only the flip-flop will be activate. Okay, so now let's see the circuit diagram. So this is the circuit diagram of the D type flip-flop. So this is it look like exactly SR flip-flop, except this NOT gate we are having the D type flip-flop we are having SR flip-flops. That is nothing but this D type flip-flop will be considered as the NAND logics. That means SR latch will be connected with the NAND logic, as well as the input gates also connected with the NAND logic. Okay, so the D type flip-flop will be connected with the NAND logic, and here we have only single input. So that's why here the D input will be as it is equal to the S input of the first path. And what about the R input means here? So the D type flip-flop will be connected as NOT gate to the R input. Okay, so then automatically this will be equal to the S, and this input will be complement of the R input. And also we are connecting one clock signal to the both the NAND gates of the one of input. Okay, so and here coming to third and fourth NAND gates. So here one of the input is directly connected to the output from the first gate, and fourth gate of the one of input is connected, that is input of this second of output is connected as input of the fourth gate. And also Q in complement and Q complement will be connected to the one more input of the third and fourth NAND gates. Okay, so now let's see the working principle. Here we have a truth table, so that is nothing but we have to find out the relation between inputs and outputs. So what is the working principle behind in that D flip-flop means whatever the present input we are having, so that will be the next output we are getting. Okay, so what is meant by output here means D flip-flop is nothing but present input will be going to the output after application of pulse. So whenever we are applying the clock pulse, so then only whatever the input we are applying here, that will be present at the output side. So simply we can say that input is equal to the output path here. Okay, so now we'll see whenever the clock signal is 0, so that is nothing but whenever the clock signal is low, automatically we can say that whenever the clock signal is low, automatically the output operation will be has no change operation. So that means the total circuit will not get any output. So the input path will be considered as the output path. So compulsory there is no change of operation we are getting whenever the clock pulse is 0. So that means D input is 0 and the output will be also 0, or we can say that that is nothing but no change operation. Okay, so now coming to the whenever the clock is high, so that is nothing but whenever the clock signal is high, automatically we are having the input possibilities. That means whenever the clock signal is high, then only the clock circuit will be activate position. Okay, so already I explained in the SR flip-flop, whenever the clock signal is 0, then automatically the total circuit will be in off position, that will be goes to the disabled. Okay, so we didn't get any results in the input path and we didn't get any results in the output path. Okay, we won't get any outputs and inputs because the clock pulse will be in inactive position. So if the clock pulse is in active position, so whenever it is in high position, so the clock is high position, it is connected to the logic 1. So then automatically the inputs, that means the circuit is in activate position. So then only the inputs are connected to the circuit. Okay, so at that time, so we are getting the possibilities. Okay, so how to get that possibilities means whenever the clock pulse is activated, inputs are activated, right? So here how many inputs we are having for the D flip-flop? So single input, right? So single input means now we have to find out the binary possibilities. So if you are having single input, so then how many possibilities we are getting means for 2 power n we have the formula for the possibilities. So if you are having single possibility no, so single input no, so then substitute in the place of small n, so then you may get the possibilities. So the two possibilities either 0 or 1 we can represent, right? So here you can represent it as whenever the clock is high, we may get the possibilities are either 0 or 1. Okay, two possibilities we are getting. So that two possibility I can substitute in the input path. So now we'll see that first possibility is coming to 0. Okay, so whenever the D input is 0, so at that time the D flip-flop will goes to the reset position. So then the output in the representation of binary is 0. Okay, so remember that one, whenever the clock signal is high, the data will be connected to the whole the circuit. So then only we'll get the output is reset output. So whenever the clock signal is high, the input will be high, that means input will be connected to the 1. So then automatically the output will be get it as set operation. Okay, so remember this one. So here the both outputs will be whenever the D input as 0, whenever the clock pulse is applied to the logic 1, so then automatically the inputs are connected to the output path. So then you may get the input possibilities are 0 because we have only single input. So that two possibilities are either 0 or 1. So for 0 we'll get the result as reset, and for 1 we'll get the result as set. So now I will show that how to get the reset position, that means 0, and how to get the set position for input 1. So now we'll see here. So now I am applying the case 1. Okay, so I will substitute these inputs in this gate. Okay, so what we will get now, we will check it. So first D input as 0 whenever the clock is 1. So here both the conditions will be applied as whenever the clock is connected 1. Okay, so then only we may get the outputs. Okay, so if the clock signal is 1, the input is 0. So what is the output we are collecting means, for the first case the gate 1 I have to find out the result is. Okay, so from gate 1 G1 result is nothing but it should be connected as one of the clock, and another one is S is equals to D, right? So S is equal to D is nothing but one input is D and another input is clock. So D input value is nothing but 0 and the one input clock is nothing but that is 1. So in between which gate we are having? NAND gate, right? So already I explained what is the NAND gate output. So NAND gate output is nothing but that is A into B whole complement. Okay, so you can substitute the values 0 into 1 whole complement. So 0 into anything, so 0, 0 complement means 1. So this is the gate 1 result. Like this way you can find it the second one also. So second one means 1 is connected as D, but here up to here we can say that D. But the D gate is connected here not. Right? So this is our NOT gate. No, NOT gate is nothing but complement. So D complement we are getting here. So R is nothing but that is equal to the D complement. So one is D complement and another input is R. So D complement is nothing but what is the result we are getting? So here D complement and R for D2 gate, G2 gate, right? So D complement is nothing but 0 complement. 0 complement is what? 1. So 1 into what is the R value here? So R value is nothing but we can say that D value, right? So R value is nothing but here both will be equal to the input path, because here SR, this is the D flip-flop modified circuit of the SR flip-flop. So that means in the place of SR we have the inputs D and D complement. So here I am writing D is equals to the S and D complement is equals to the R. That is the, in place of SR we are getting the inputs is D and D complement. So D complement is 1 and another input is what? Clock. So clock is also 1, no? So 1 into 1, 1 complement is nothing but 0. Now we have the G1 result and G2 result. Now substituting third and fourth also. Find out the third gate result. So third gate result is nothing but one input we can consider as the exactly first gate output. First gate output is what? 1. into here one more input we can consider from the here, right? So here if how to take that value, how to take this input value means here you have to mention, so this may be considered as the next state value, so then this input you have to consider as the present state value. So present state, nth state is nothing but what about the next stage, n plus 1 stage we can consider as the next state. So qn complement. So now this qn complement will be take it from here, so and next the qn will be collected from here. Okay, so now these are the one of the input for the third and fourth gate. Now we will substitute in third gate the inputs. So one is gate 1 result and another one is qn complement. So qn complement, so whole complement 1 into qn complement is qn complement and whole complement we are having, so that is nothing but qn. So now coming to the next one, G4 result. So G4 result is nothing but one is G2 output. G2 output is 0 into one more input what? Qn. So Qn complement. So 0 into anything 0. 0 complement means what is the result 0 complement? 1. So now we can say that here G3 result is exactly equal to the Qn plus 1 result. Is it right? Check it. G3 result is exactly equal to the Qn plus 1 result. But what we are getting the Qn plus 1 result? So that is G3. So that is nothing but it is approximately equal to the Qn. Like this way. So G4 gate result is nothing but complement result. So Qn plus 1 complement, that is approximately equal to what? G4 result. So 1. You can say that complement value is 1 means normal value is what? So that is nothing but 0 from this we can consider. Okay, already we know here complement value is clear, that is nothing but binary number is 1. So then what about the normal path value? So if complement value is 1 means normal path value will be 0. So that's why I can represent it here. If D input value will be 0, so then we are getting the result is 0 only for normal path. So that we can consider as the reset position. So like this way if you are finding the case 2 also. Okay, so the G1 result will be considered as, so here we can consider D input as 1. Okay, D is equal to 1, you have to substitute. So 1 into clock is also 1, 1 complement means 0. So here 1 into 1, 1 complement is 0. Like this G2 result also I can find it. So that is nothing but D complement and clock. So D complement is nothing but 1 complement, that is 0. So 0 into 1, 0 complement is 1. So now find it G3 value here, gate 3. So gate 3 is nothing but one is gate 1 result and another one is Qn complement. So gate 1 result is 0. So 0 into Qn complement whole complement. So here 0 into anything 0, 0 complement is 1. So directly we can say that from G3 gate, G3 path is nothing but normal path. So normal path value is nothing but 1. So directly I can write it here, normal path value is that is 1. So we can say that this is the set position. Okay, so like this way we are getting the result for the D flip-flop. So in truth table we'll say that that is nothing but if D input is 0 then we are getting the output is reset. If D input is 1 then we are getting the result is set. Okay, so this is the D type flip-flop. So now we'll see the next concept, that is nothing but JK flip-flop. So see here, JK flip-flop is nothing but this is also one of the modified circuit of SR flip-flop, but the 2 more connections is extra here. 2 more inputs we are connecting extra for this. Okay, so but except the 2 more connections, it is equal to the SR flip-flop only. Okay, so see here the logic symbol of JK flip-flop. So it consists of 2 inputs J and K and the 2 outputs Q and Q complement. So and one more clock input we have to connect it for each and every flip-flop, right? So with the help of clock only every flip-flop can work, right? So that means if the clock signal is in enabled position then only the circuit will be enabled. That means inputs and outputs are enabled. Okay, so here this is the circuit diagram for the JK flip-flop. So see here, except the down and up connection, Okay, except this connection and except this connection, the remaining circuit will be look like a SR flip-flop only. Okay, so we have one clock signal and we have two inputs. So the same 4 NAND gates we are connecting, and this is one type of SR latch. Okay, so here the J input consider of that means the first NAND gate consists of the totally 3 inputs. One is J input and another one is clock, and the another one is this input. One of the input is first NAND gate of one of the input is connected to the present state of the complement output. See here, present state of the complement output we are connecting. That is nothing but if you are considering this next state output Qn plus 1 complement. So then we can consider this is the Qn complement and this is the Qn. Okay, so that means we can say that so this JK flip-flop consists of the first NAND gate consists of 3 inputs. One is J and another one is clock, and another input will collected from the complement path of the present state. Output will be considered as input of first NAND gate. Like this way, the second NAND gate is also connecting the 3 inputs. So in that the first input we can consider as K and the second input we can consider as clock, and the third input we should connected from the present input of normal path. Okay, that is Qn. So now I can represent it. This line we can take it from the Qn complement. So you can, as it is represented here, Qn complement, and this is the normal value, that is Qn. Okay, so now coming to the truth table, here the circuit diagram is this one, and here the third NAND gate of one of the input is connected as output of the first, and the fourth gate of the one of the input is considered as the second gate of output, and the remaining two inputs of the two NAND gates will be connected from the present states of inputs.